Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 28 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3372. Maximize the number of target nodes after connecting trees 1. Let's read the problem statement first. There exist two undirected trees with n and m nodes. Okay, with distinct labels in the ranges 0 to n minus 1 and 0 to m minus 1 respectively. All right, you are given two 2D integer arrays edges 1 and edges 2 of lengths n minus 1 and m minus 1 respectively. Okay, so see this edges 1 array. This is index 0, index 1, index 2, index 3. Okay, this is 0 index, 1 index, 2 index, 3 index, 4 index, 5 index and 6 index. Okay, and what is the length of this edges one? Length is nothing but 4, right here, right? And for edges 2, what is the total length? 7, right? Okay, so here length given as n minus 1. Okay, so this is nothing but n minus 1 value. Okay, n minus 1 value, and this is nothing but let's say m minus 1 value. Okay, m minus 1 value, right? So we have labels of these nodes from 0 to n minus 1. Okay, so 0 to 4 and here 0 to 7. Okay, so if I draw this, so here see 0 to 4 we have nodes label, right? 0 1 2 3 4 and okay, and in this case 0 to 7, 0 1 2 3 4 5 6 7. Okay, all right, so here let's understand what we are doing after that. Where edges of one of I, A and B indicates that there is an edge between nodes A and B in the first tree, and edges of 2 of I, UI, VI indicates that there is an edge between nodes UI and VI in the second tree. You are also given an integer k. Okay, so integer k value is also given to us, and here 0 to 1 there is one edge. Okay, so that's why I'm drawing here. 0 to 2 there is one edge, then 2 to 3 there is one edge, and then 2 to 4 there is one edge. Okay, so this is how we draw this tree 1. Okay, now see this tree to 0 to 1. Okay, then 0 to 2, then 0 to 3, then at index 3 we have 2 to 7, so here 2 to 7. Okay, then 1 to 4, 1 to 4, then 4 to 5 and 4 to 6. All right, so this is how we draw tree 2, right? So this is undirected tree, right? Undirected tree given to us, right? Okay, and we have also given an integer k. All right, so now next after that, node u is the target to node v if the number of edges on the path from u to v is less than or equal to k. Okay, note that a node is always target to itself, right? Okay, now what we have to return? We have to return an array of n integers answer, where answer of I is the maximum possible number of nodes target to node I of the first tree if you have to connect one node from the first tree to another node in the second tree. Okay, note that queries are independent from each other. That is, for every query you will remove the added edge before proceeding to the next query. Okay, so now let's understand this with this example. Okay, so what we need to do here? Okay, so here from if you see in tree 1 we have how many nodes? We have nodes 0 1 2 3 4. Okay, so let's draw this. Okay, so this is, let's say, node 0. Okay, index 0, right? Node 1. Okay, this is node 2, this is node 3, and this is node 4, right? Okay, so here we have to return an array of n integers answer. Okay, and n is nothing but 3 1, right? Number of nodes in tree 1, right? So we have to return an array of n integers answer, where answer for I is the maximum possible number of nodes targeted to node I. Okay, target to node I. Okay, so first we have to check this and this. Okay, target to node I. So this is why we are creating this array, right? So 0 1 2 3. Okay, so here where we are, we have to return an array of n integers answer, where answer of I is the maximum possible number of nodes target to node I of the first tree if you have to connect one node from the first tree to another node in the second tree. Okay, and here node u is the target to node v if the number of edges on the path from u to v, okay, is less than or equal to k. Okay, this is condition given to us. Okay, and note that a node is always target to itself. All right, so now here let's see for this 0 first. Okay, from this 0, now let's consider just this tree 1. Okay, just consider this tree 1 only. Okay, don't consider this right now. Okay, only tree 1, right? So from 0, right, so from 0, if I see here, there is just one edge, right? Okay, k value is 2 right now. K value given as 2. Okay, k value is 2, right? So this is at just distance 1. All right, okay, and this is at just distance 1. Okay, this node 2 and this node 1 is also at distance just distance 1. Okay, and this 0 is at distance 0 only right now. Okay, right? So here this note that a node is always target to itself. Okay, so here, all right, so in just one edge I can go to this, in just one edge I can go to this. Okay, I'm checking from 0 only, right? And same way, this is one edge, and the same way this is second edge, right? From this to 2 to 3 also I can go, right? Same way from 2 to 4 also I can go, right? So if you see, this is one path. Okay, this is one path this way, and this is also one path. Okay, this and then this, right? So here I will decrement the value. Okay, k is equal to 1. Okay, here k is equal to 1. Same way here k is equal to 1. Okay, and then here k is equal to 0, right? And here also k is equal to 0, right? And after that I can't fetch anything, right? Because we need minimum distance less than equal to k only, right? So node u is a target to node v if the number of edges on the path from u to v is less than or equal to k only, right? So this value is also less than equal to k, right, at 2 distance only, right? So from this 0, if you see, you are going to cover this node, you are going to cover this node, you are going to cover this, you are going to cover this, and this automatically we are going to cover. Okay, because node is always target to itself, right? So here just for tree 1, okay, my output is going to be 1 2 3 4 5. Okay, my output is going to be 5, right? Okay, just for node 0 I'm saying, right? All right, okay, this is done, right? So here I'm writing 5. Okay, done. Now after that, for same way we have to check node 1 also. Okay, so here k value is equal to 2, right? So from here, at just one distance, okay, at just one distance we can cover this, right? And at just one distance we can cover this also. Okay, and that's it, right? Here k value is 2, right? And here let's say I decrement this k value, now it is going to become 1, and now let's say I decrement here one more time, it is going to become 0, and that's it. Okay, after that there is nothing. After that we can't check this because this is at distance 3, 1 2 and 3 distance. Okay, only less than equal to k, right? So only 3 nodes we are going to cover, 1 0 and 2. Okay, 1 itself and 0 and 2. So here I'm writing 3. Okay, now same way you have to do the same thing for 2 and 3 also. Okay, so here let me just remove this. Okay, so here we are writing 3. Okay, now for 2, so for 2 you can cover this. Okay, this is at one distance, same way this is also at one distance, this is also at one distance, and you can also cover this also, right? 1 and 2. Okay, so you are going to cover all 5 here. Okay, 1 2 3 4 5 or 5. Okay, so you are writing 5 here, right? This is for 2. All right, so here a 5 3 and here also 5. Done. All right, okay, now for 3 you are going to cover this at 1. Okay, this at 1, and then this at 2. Okay, and this at 2 also. Okay, that's it. So you are going to cover this node, this node, this node, and this total 4 nodes you are going to cover, right? So here you are going to write 4. Okay, so here let me write 4 here. Done. Okay, now same way for 4, you are going to cover this node 2 at 1 distance, this node 3 at 2 distance, and then this 0 at 2 distance. Okay, so only 1 2 3 4. Okay, 4 itself, 3 2 and node 0. Okay, so here you are going to write 4. Okay, here you're going to write 4. All right, so this is done. Okay, so this is for tree 1 only, right? How many nodes we are going to cover? Okay, how many nodes are there in target? Okay, from 0, from 1, from 2 3. Okay, now here we can connect these two trees also, right? So this is just my step 1. Okay, we can also connect these two trees, right, by one edge, right? This is given the problem statement. right? Return an array of n integers answer where answer 5 is the maximum possible numbers of nodes started to node I of the first tree if you have to connect one node from the first tree to the another node in the second tree. Okay, this is also one possibility, right? So here from, let's say I'm checking from this 0 now, again from 0, right? From 0 I want to see, right? So here you have many possibilities now. You can connect this, right? You can connect this also, right? You can connect this also, right? You can connect this also. All right, there are many possibilities, right? So now let's first tell me, can I connect this with this? Okay, tell me, can I connect this 4 and this 7? Okay, so here see, from I'm starting from this 0. Okay, I'm checking from this 0, right? So here this 2 is at 1 distance, okay, no 2. This 4 is at 2 distance, then after that this is at 3 distance now. So no, there is no better result. Okay, this is not better, not a good result, right? Right, it's only 5 only. Okay, it was 5 also, and here also it's 5 only, because this 7 is at distance 3, right? 1h, 2h, and this, right? So there is no, this is not a good thing, right? If we connect this 4 and 7, right? Okay, now instead of this 4 to 7, okay, if you connect this with this, okay, let's say this with this, right? So now is there any answer is possible now, better answer other than this 5, let's say? Okay, from just 0 now you can connect to this at 1, okay, this 2, okay, this node 2 you are connecting with this node 0 at 1 distance, and then this you are going to connect at a 2 distance. Okay, right? So that's it, okay, that's it, right? So here now what is the answer you are going to get for this 0? This 1, this 2, this itself, and then this 3, 4, okay, then this 5, and then 6 total, right? So here 1, 2, 3, 4, 5, and this, then this 6. Okay, this 6 you are getting, right? Now this 6, now this 6 is a better result than this 5, but is there any other better way? Let's see that. Okay, so here this is also better way na, if you connect this 0 with this 0. Now why this is going to give me best result? Okay, I am connecting this 0 with 0, or this 0 with the 2, or this 0 with 3, or this 0 with 1, 0 with 4, 0 with 7, 5 and 6. Okay, why this is going to give better result? Because this time I'm starting from 0 itself. Okay, I'm not wasting my one edge here. Okay, so here when I was trying to connect this 2 with the other tree, for this 3 with other 3, this 4 with other node of the tree, right? So I was wasting some edges, right? I was wasting some edges. Okay, so this is not a good thing, right? So now what we need to do, okay, if I am checking for 0, so just try to make the connection from this 0 only to the other part of tree. Okay, so now you have many possibilities. You can connect this 0 with 0, okay, you can connect with this 0 with the 2, okay, you can connect this 0 with 7. Okay, so there are many possibilities now also, right? So from here one thing is clear: if you are checking with 0, then try to connect this 0 only with some other node of the tree 2. Okay, don't try to connect 2 with this other nodes of the tree, okay, or 4, right? If you are checking for 0, right? So if you are checking for node 0, then try to connect this node 0 only with other node of the tree, right? So this is the main thing, right? Okay, so now here now if you connect this, okay, if you use this path, right, so here you are going to waste one edge, right? So here k value is 2 initially. So if you are going to connect this, so here when you are going to reach here to this tree, your k value is going to be decremented by 1. Okay, so k is equal to 1 now, right? So now from here also, if you see, you are going to cover this, and then also there are 3 more possibilities now. This 0 is at a distance 1, okay, then this 1 is at distance 2, which is okay, this 3 is at distance 2, which is okay, this 2 is at distance 2, which is okay, right? So for this 0, you are going to get how many more nodes of tree 2? So here 1, 2, 3 and 4 nodes more, okay, of tree 2, okay, and these also we can access, right? So here 5 plus 4 if you go, okay, so you are going to get 9 this time, and 9 is your output actually, right? 9 is your output here, right? Okay, but let's not write here 9 first. let me show you a few more things first. Okay, so you with this 0, right, you are going to get 4. Okay, 4. Okay, now same way this is also one possibility now. If you connect this 0 with this 7, okay, let me just remove this. Okay, if you connect this 0 with 7, right, then also check this is one edge and this is 2. Okay, so here 1 and 2 only. Okay, 2 this time 2. Okay, so here for this 0, you are getting here, let me use some other pencil, white color let's use. Okay, for this 0 you are getting 4, right, 1 this and this. Okay, right, now this is for 0, right. Now for this 7 you are getting just 2 now. If you connect this 0 with 7, you are getting just 2. Okay, one distance, two distance. Okay, only 2, right, only 2 you are getting, right. Okay, now after that, if you connect this 0 with the 2, okay, if you connect this 0 with the 2, then also you are getting here 2 7 and 0. Okay, one edge, two edge, here this edge. Okay, so 2 is at distance 1 of this 0, then this 7 is at distance 2, this 0 is at distance 2 only, right. So here this time you are getting 3. Okay, if you connect this 0 with 2, then output is 3 from this tree 2, right. Same way you are going to check for others also. Okay, if you connect this 0 with this 1, right, so this is one edge, then 2 edge, 2 edge. Okay, so here 1 2 3, again here 3 only, right. Same way if you connect with the 4, then what you are going to get 0 and this 4, one edge, and then this second, this second, this second. Okay, 1 2 3 4, then 4 you are getting. Okay, and same way here if you connect this 0 with 3, then 1 this and this, or only 2. Okay, this is what you are getting, right. So this is your tree 2. Okay, so here in this tree 1 we are using DFS, right. Let's say we are using DFS. Okay, so first k is equal to 2 we call, then we reach here, then DFS for k is equal to 1 we are going to call. Here also DFS for k is equal to 1, then here we are going to call DFS for k is equal to 0, DFS for k of 0. Okay, so here we are starting from k is equal to 2 every time, right. But if we are going to make any connection from tree 1 to tree 2, then definitely there is going to be one edge in between, right. So if there is an edge in between, then definitely we have to if we do the same DFS here on tree 2, okay, on tree 2, then in that case we have to start from k value minus 1. Okay, whatever the k value given to us, just subtract 1 from it. Okay, so here k minus 1, because there is already going to be one edge in between. Okay, so here this is for tree 1. Okay, same way if for tree 2 I draw this same. Okay, so here what is the total length? We have 7, right. So let's draw this 0 to 6. Okay, let's draw this same thing. Okay, let's fill this then. All right, this is done. Okay, so 0 here, 0 here, 1 here, 2 here, 3 here, 4 here, then 5 here, and then 6 here. Okay, now same way here we are applying DFS, right, and we are getting this value 5 3 5 4 4. Okay, same way here you also you have to apply the DFS. Okay, but here you are going to start from k is equal to 1. Okay, so whatever the k value, subtract 1 from it, because there is an edge. Okay, we are going to use that edge for connection, right. So here for this 0, how many nodes we are going to connect at distance 1, how many nodes are at distance 1, this 2, this 3, this 1, and this itself, right. So total 4. So here I'm writing 4. Okay, now this 2, how many nodes are at distance 1? Okay, this itself, this 7, and this 0. So that is why I am for this 2, right, for I'm writing for which let's say 1. Okay, let's follow the order now. This is 0 1. Okay, for 1 let's see. So for 1 at distance 1, this 0, this 4, and this 1 itself, total 3. Okay, that is why I'm writing 3 here. Same way at 2, distance 1, so this 0, this 7, and this 2 itself, total 3. Okay, that is why I'm writing 3 here. For this 3, only 2 nodes, okay, which is 3 and this 0. Okay, at distance 1, right. So here I'm writing 2, right, sorry, here it is 2, right. Okay, now for this 4, at distance 1, okay, this 1, this 5, this 6, and this 4 itself, that is my 4. Okay, so let's write 4 here. Now same way for 5, distance 1, only 4 is there, and 5 itself, so here 2. Now for this 6 distance to 1 2, okay, 6 4 and 6, okay, so 2 and 7 is also there now. All right, so we have nodes from 0 to m, okay, so 7 we have to write. All right, so here 7 is also there. Let me just extend it. 7, okay, so for this 7 also at distance 1 2 only, right? So total 2, right? 7 and 2, okay, so here we are writing 2. All right, so this is what you need to do. Okay, so here we are calling DFS starting from k value, okay, then we are subtracting k. Here also we are calling DFS, okay, we are going to pre-calculate this, right? We are going to make one connection, okay, so we are going to make one connection using one edge. So here we are going to do DFS with k minus 1 value, right? Start from k minus 1, that is 1, okay, and we are going to pre-calculate all these values, right? Now here, okay, this is done. We are going to calculate this, okay. Now after that, if you are going to make any connection, definitely you are going to pick the max value, whatever the max value that you are going to get from here, like here 4, here 3. So here tell me, are you going to make the connection of this 0 with 7? No, because only 2 is the output that I am going to get from this tree. Okay, if you make the connection of 0 with 7 or from this tree, only 2 is the connection, 2 is the output you are going to get. So you are going to choose the maximum value from this tree too. Okay, so after that, right, so here for this one also, if you are going to make the connection, you can choose this 0 or this 4. Okay, this is your choice, right? So what you need to do here, just choose the maximum value this from this tree too, whatever the max value. So max value from here, if you see, it's nothing but 4. Okay, so you can choose this node 0 to make the connection, or you can choose this node 4 to make any connection. This is your choice, right? So from this node 0, just make a connection with, let's say, node 0, right? So here 4 is the output that you are going to get. Okay, so here just do plus 4. Okay, for this node 1 also, let's try to make the connection with node 0 only of this tree. Then 4 is the output that you are going to get. So here plus 4. Same way here also plus 4. Node 2 connect with 0. Okay, for node 3 also connected with 0. So hereby I'm writing plus 5 plus 4 only. Here also plus 4 only. Here also plus 4 only. Okay, so if you do plus 4 here, okay, in this, so you are going to get 9 here. Here you are going to get 7. Here you are going to get 9, here you are going to get 8, and here you are going to get 8. Okay, so 9 7 9 8 8, 9 7 9 8 8. This is your output, simple DFS, right? So this is the same thing that you need to write, okay, in the code also. Very simple code for this one. Let's write the code and I will explain the code side by side also. Okay, so but this is the simple approach that you need to do. Okay, so here just important thing, here we are going to implement a DFS with k is equal to 2 value, and here we are going to implement the DFS with k is equal to 1 value. We are going to pre-calculate all these things, then we are going to choose max value from here, then just add that value everywhere. Okay, and that is going to your final output. That's it. Okay, now let's write the code for this using DFS first. Okay, so what you need to do here, let's get started. First, length, let's calculate the length. Okay, n is equal to edges 1 dot length plus 1. Okay, and same way calculate m also is equal to edges 2 dot length plus 1. Done. All right, now after that, let me just maximize the screen. Okay, now here create two arrays, count 1 and count 2. Okay, so here int count 1 is equal to new int, and here after that, okay, you can do one thing here, just call one method. Okay, build, and here edges of 1, and here this time we are going to pass k, let's say, right, k. And same way for count 2, if you have to fill count 2, here also you are going to call this build method. Okay, and here this time edges of 2, and here you are, you already know why we are going to pass k minus 1 this time. Okay, so this is for 3 2, right? So we are going to calculate the count 1 and count 2. Okay, these two arrays, this 5 5 3 5 4 4 and 4 3 3 2 4 2 2. Okay, we are going to calculate these two arrays. Okay, and let's say this build and this build, okay, this method is going to give me that. Okay, now after that we have to calculate the max count from this count 2, right? So what you need to do here, create one variable int max count from for 2. Okay, tree 2, from tree 2 we are going to get. Okay, so here you can use for each loop for int c is equal to count 2. All right, we are going to iterate over all the counts, and if c value is greater than max count 2, right, and in that case you have to just update max count of 2 with c. Okay, and from here we are just going to get the max count. Okay, now how we are going to update the result? So create one result array, new int n. Okay, and then just run one loop for int I is equal to 0, I is less than n I plus plus. Okay, so whatever the max value we are going to get from this 4, so we have to add this 4 in this count 1. Okay, everywhere, right? So this is how we are going to get the result. Okay, so here result of I is equal to count 1 of I plus your max count 2. Okay, that's it. Okay, and from here, once this is done, and from here you have to just simply return result. Okay, that's it. Okay, so this is a simple code, okay, that we are going to do. Now we are going to write this build method. Okay, but this piece of code, it is going to be same for BFS also, right? So first I am writing the code for DFS, then I will write the for BFS. Okay, using same code. Okay, only few things need to be changed for BFS. Okay, now this is done. Now let's write this build method. Okay, so private, this build method is also going to be remain same for both DFS and BFS. Okay, only few changes are there. So build, so in this build, how we are going to create? Okay, we are going to build the trees, right? So here int, okay, and here edges 1, let's pass edges. Okay, let's say edges. Okay, so first we are going to count build for tree 1. Okay, this is nothing but your tree 1, and then you are going to call the same method for tree 2. Okay, so here what we are going to pass, we are going to pass the edges, okay, for that particular tree, and k value, right, whatever the k value we have, right? So now inside this, first let's calculate the length of edges. So here you can write edges dot length plus 1, and then here let's create one array list, okay, to calculate the to count the children's. Okay, so add the children's. Okay, so list, here list, and here inside this integer, let's say children is equal to new array list. All right, this is done. Then after that, what you need to do, just iterate over all the edges we have, right? Int I is equal to 0, I is less than n. Okay, so this is the number of nodes we have now, labeled from 0 to n minus 1, right? So for all these nodes now, I will just create one array list, right? So here what I'm going to do, children dot add, and I will just initialize new array list, empty array list right now. Okay, then I will add the children's for that particular nodes. Okay, so this is done. All right, now just iterate over all the edges that we have. So for each loop you can use edge in the edges. All right, and here how you're going to do this, so we have untitled graph. Okay, children dot get 0, here edge of 0. Okay, right, so this is done. Here dot add edge of 1, right? We are just going to build the graph, right? Simple, right? Here just copy this. So if u to v there is an edge, then definitely v to u also there is one edge. Okay, so children dot get 1 dot add edge 0. Okay, done. Okay, so we have built the graph, right? Now after that, here how you are going to update this value. Okay, int create one array result, new int, and here n. Now after that you have to call the DFS. Okay, so this is what you have to fill, right? 5355 544. Okay, so you are going to call the DFS for this. Okay, you already built the graph 0 to 1, there is one connection, you already built that. Okay, so you have already created a list here. Okay, so here 0, okay, 1 2 3 4. Okay, so these are the nodes, different nodes. Okay, so 0 you have connection from 1 and 2. Okay, so this is the list you have created. Okay, for 1 connection is just 0. For this 2 the children are 0, 3 and 4. Okay, this you, but this is what you have built, right? For 3 2, right? Okay, and this 4 you have just 2, right? So these are the different relations, right? Same way 3 to 2 and same way 2 to 3 also you can go, right? So this is what actually you build here, right? Okay, so children dot add new array list, then you have to iterate over all the edges. Okay, so 0 to 1, right? So this is how you are going to fill. All right, okay, this is done. Now after that, what you need to do, okay, just run iterate over all the nodes we have. Okay, int I is equal to 0, I is less than n, and here I plus plus, and inside this you have to update the result of I value. Okay, so how you are going to do that? Just you are going to call DFS. Okay, so in this problem we have to call this DFS method, and in the BFS approach we have to use BFS here. Okay, so that is going to be one change. All right, so here I minus 1. Okay, and here you are going to pass children, and here you are going to pass k. All right, okay, this is done, and from here you have to just simply return result. Okay, return result. All right, so now let me explain this DFS, right? So here result of I, that simply means you are going to update this 53544. Okay, so now let's use this DFS. Okay, how this DFS is going to work, let's see that. Okay, so only few lines of code for this one, and then it's end. Okay, only I think 6 to 7 lines, that's it. Okay, then this DFS approach will end. Okay, so now here how you're going to fill this. So private int here write DFS, and here first I. Okay, but we are going to pass I is nothing but the node, then parent. Okay, so initially for 0 nodes there is no parent, so here I will say parent. Okay, and then after that children. Okay, children's we have to check, right? So list, and here this is nothing but list of integer, right? And here children, and here you have to pass k. Okay, int k. Right, now inside this, if k value is less than 0, okay, k value is less than 0, then in that case you have to stop. Now you have to simply return 0, that's it. Okay, and here the node itself is always in the target, right? So here take start from result is equal to 1, right? And then check all the childs. Okay, int child of all these nodes. Okay, so child of children dot get node. Okay, and here inside this, if the child is equal to parent, then just continue. Okay, we have already calculated this, child is equal to parent, then just continue. All right, and here otherwise just update the result. Okay, so how you are going to update result? The result is equal to result plus, and next time you have to again call this, use this DFS method. And now in this DFS method, next time your node is going to be the child. Okay, your parent is going to be the current node. Okay, and here you have to just pass the children. All right, and here you have to update the k as k minus 1. Okay, simple DFS code, right? And here in the end you have to just simply return result. That's it. Okay, that's it. Now let's try to run this code and see if there are any code issues. We'll try to fix that. So yes, there are some issues, let's fix that. Okay, c variable. Okay, why it is capital? Where is c? Where is c we are using? Okay, here it should be small, right? Let's run it again and see. All right, so here also int result is equal to new int n. Okay, so why we are using this here? Okay, this for loops here, and here new int n is equal to edges 1 or length. All right, okay, okay, here this is arena. Why I use this? Let's run it again. Now here c capital, I think somewhere, right? Here c small. Let's run it again. Okay, nice. So all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So this is the code for DFS approach. Okay, let me minimize the screen. This is a code for DFS approach. Okay, now we will solve the same problem using BFS. Okay, so what are the changes that you need to do? This part we don't need now. Okay, this DFS part, so we are just going to delete this. Now I'm moving to a BFS approach. Okay, delete this. Now here, instead of DFS, just we are going to call BFS. Okay, and here what you need to do in this BFS, you have to just simply pass what are the requirements now. Just pass I, and here do one thing, remove this, and here now you do one thing. Instead of children, let's use adjacency. Okay, control find, replace with ADJ, adjacency. All right, for simplicity. All right, so I have changed this to adjacent. Okay, this word adjacency here, adjacency here. Okay, so now here just pass this BFS I, and here just pass this adjacency array list. Okay, ADJ, and here just pass key value. That's it. Okay, for this BFS. Okay, and now let's write the code for BFS. So here private int. Okay, we are going to use q and all. Okay, BFS, and here you have to just pass start. Okay, from where you're going to start, and here just copy this, you can paste it here. Let's save some time, and then after that here you have to just pass k value. Okay, and now inside this let's write the code. Okay, let me just maximize the screen. All right, so now inside this int count is equal to 0. All right, and here just create one queue, and in this queue just pass one int array. All right, and here just use queue, and here new linked list. All right, this is done. And now after that just we have to keep track of the visited nodes also. So here visited, you can do visited, and here new boolean, and here just pass this adjacency array list size. Okay, adjacency dot size. All right, this is done. All right, okay, now in the queue first just offer that particular start with node. Okay, queue dot offer. Here you have to just pass new int. Okay, and you are passing array now, so here just pass start and 0 initially. Okay, so this is done. Now after that just mark this visited of start to true. Okay, visited of start is equal to true, and then once this is done, then just run one while loop, and here just make sure until our queue is not empty, we have to just execute this while loop. Okay, so queue is empty. All right, and here inside this take one cur new here just queue dot poll. Okay, just all the element queue dot poll. All right, and here node int node is equal to cur 0. Okay, so here at cur 0 we have that particular node, right? And here at distance 1, okay, we have the distance. Okay, just here you can write cur 1, right? These are the two things we are passing, right? So this is the node that we are passing in the start, right? This start. Okay, the node we are passing, and here after that the distance. Okay, 0 to itself. All right, so now after that we are going to do this, right? And here we are just going to make sure, okay, if distance is becoming greater than this k value, okay, then in that case you have to do just continue, right? If distance is k, right? Okay, otherwise you have to just increment the count plus plus. Okay, and then here you have to check the neighbors. For int neighbor, here adjacency dot get that particular node. Okay, right? So here inside this, if you haven't visited that particular neighbor, so here just make that check. If not visited dot this neighbor. Okay, NEIGHBOR. Okay, neighbor. If you haven't visited this neighbor, then after that here you have to just mark this visited of neighbor. Okay, let's just copy now, visited of neighbor to true. Okay, All right, and next time in the cube, what you have to do, you have to just offer here new int. Okay, now this time you have to just offer that neighbor, and you have to calculate update the distance by 1. Okay, so neighbor, NEIGHBOR. Okay, spelling is correct, right? And here you have to write distance plus 1, right? So this is nothing but a BFS approach, right? And that's it. And here just simply return a count, so whatever the count you have, right? So that's it. Now let's run the code and see if the encode issue. We'll try to fix that. So see, all the test cases has been selected, right? So now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand both the approaches, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you guys in the next video. Thank you. Bye bye.